Hello, I simulate my project using CST software to design wideband MIMO antenna at operating frequency from 0.85 to 2.6 GHz. Here are the steps that will be done. Firstly, as you can see, the patch is like an octagon shape. You can see the details that I have been do here. For the chamfer edge, the straight line at the side, you need to pick edge that you want to do. For example, in here, and then you can pick edge, go to modeling, pick edge, and then double click at the edge you want to make. And then go to, after double click it, go to blend and choose chamfer edge. As here you can see, the chamfer width is 97.4 and the angle. And for the material, ground and patch is copper. Here. And also the ground. For at the ground, the slot have been inserted here for each L slot. And the material is vacuum. Since I want to cut it out, I will subtract it. So the slot will be created. For the port, I'm using waveguide port here. As you can see here, the details that need to be filled. The port that I done is 3 times bigger than the width of it. After setting the port, I can run it. But if I want to see the range, if I want to decide the best dimension for any parameter, I can just do parameter sweep and put the range from any value to value and how many samples that you want. And the result will be shown for each sample. But here I just want to run it. Okay, after simulate it, you can see the result for the S parameter at 1D result. Expand it. As you can see here, all the S parameter is below than negative 10 dB from 0.85 to 2.6. The S11 and for the isolation here. And also for the surface current, after I'm making the slot, I want to see the surface current at port 1 when it is sighted, and at port 3 at frequency 2.6 and port 3. Okay, and then I can see for the far field. This is 2D radiation pattern. At here I can see the radiation characteristic. If I want to see the E plane, I'll change it to 0 degree. Here is E plane, and then 90 degree is H plane for each port at the defined frequency that we have setting. And then to get the gain for the whole desired frequency range, which is 0.85 to 2.6 GHz, I need to run the far field for broadband first, which is it will cover for the whole range. To run for the far field broadband, I need to go to field monitor, and then choose far field, transient broadband, then transient far field. So and then OK, click OK and apply, but I have already done it. So here the result for each port for the broadband. But the details that why I want to find the far field for broadband is to get the gain. So to get the gain, I will go to post processing, then template base, go to gain, far field result, then choose gain, then all setting, I want realize gain. Then here, browse monitor, I choose broadband. Here, I will set either port 1 or port another port that I want. And then set frequency. Okay, this is 1D, catation and 3D. Max value, so click OK. Okay, for diversity gain, I'll choose this one. For directivity, I'll choose the same step, choose your far field broadband for the port that I want, 1 or 3 or 2, and then 3D, directivity, okay, and then okay. Okay, so here, and then for the ECC and diversity gain, we can just get from here correlation. This is for ECC, this is for diversity gain. For any isolation port that you want, 1, 2 or 1, 3, 3, 2s, and so on. So after evaluate, I will get to see the ECC for each isolation port. For the realized gain and directivity, the efficiency of the whole antenna we will get